One of the leading business houses in India, the Murugappa Group is a diverse conglomerate with interests that span many industries. Since 1949, Tube Investments of India Limited, the engineering arm of the Murugappa Group, has grown into an enterprise with a turnover of 5,000 crore Indian rupees, with products ranging from bicycles, automotive parts, chains for two-wheelers, industrial chains, and railway structurals. The value-conscious Indian customer is migrating towards higher quality, higher strength, higher performance structural steels in his quest for reliable infrastructure development. This is presenting a unique challenge to TMT bar manufacturers who are largely from the unorganized sector and has turned into an opportunity for TI. Marketed under the brand of TI Macho, TI has brought its quality definitions and processing standards for specialty steel, developed over 70 years of its existence, to deliver higher levels of performance in TMT bars. The Technology Center of TI spent 1 year benchmarking the best TMT bars available in the Indian market by testing and identified desirable characteristics and performance parameters to be built into TI Macho TMT bars through special processing techniques. So, what is special about the manufacture of TI Macho branded TMT bars? High quality raw material with very low phosphorus and sulfur content is used with sponge iron to meet exacting chemistry requirements of liquid steel in induction melting furnaces. Phosphorus and sulfur are impurities which bring down steel performance, and their limits are specified in the Indian standards. Sulfur lowers transverse ductility and impact toughness, both properties being related to shock resistance. Phosphorus, on the other hand, lowers ductility, toughness, and weldability in TMT bars. That is why TI Macho TMT bars routinely maintain lower levels of phosphorus and sulfur, which lets high strength be retained with higher ductility after heat treatment. It also allows the bars to be welded easily with no crack formation during welding. Manganese is another element which helps increase the strength of the bar by promoting hardenability and increasing core strength. Manganese becomes all the more important as the diameters of the bar increase, and larger diameters of TI Macho TMT bars have higher percentages of manganese to help maintain higher strengths. The liquid steel is then transferred from the furnace into a ladle. The actual chemistry of each batch is checked by taking a sample from the liquid steel and verifying the chemical content using a spectrometer. Then, the ladle is emptied into a tundish, which is part of the continuous caster and which converts the steel into cast billets. The liquid metal is converted into billets of square cross-section and solidifies on the surface during the casting process. The cast billets are then rolled in multiple passes in rolling mills, which progressively changes the rapidly cooling cast structure of the billets into a hot rolled structure. In the final hot rolling passes of the mill, the ribs are formed on the surface of TMT bars. The shape of ribs for the TI Macho brand TMT bars are specifically engineered to maximize the bond strength with concrete and are generally in accordance with international standards, meeting ideal mean projected rib area. The performance of rib geometry in terms of bond strength, is routinely verified by type testing of the bars at the Technology Center by pull-out tests from blocks of concrete, where the force required to dislodge the bar is compared with bars of the same nominal diameter but without ribs. This kind of comparative pull-out testing is specified in the Indian standards, whereas the ISO standards specify the rib geometry permissible, which is independent of concrete characteristics. Once the steel has been rolled to size, the surface of the TMT bars are quenched rapidly for a very short period of time, which converts a ring of hot steel on the outer surface to a hard structure called martensite, which gives excellent mechanical properties like strength, wear resistance and endurance to the TMT bars. TI has developed a unique technology of quenching TMT bars called the Maelstrom. This allows the TMT bars to be quenched 2 to 3 times more rapidly than in conventional quenching processes, resulting in the formation of very fine microstructures in the TMT bars, imparting superior combinations of tensile strength and ductility to the bars. This technology of quenching is unique to the process used to produce TI Macho bars. It is the fine microstructure achieved through this quenching technology that gives TI Macho TMT bars their unique properties, along with the promise of raw material purity. The microstructure achieved is routinely tested for overall dimensions of case and core using microscopes and checked for optimal characteristics and hardness. The bars are then cut into 60-meter lengths on a runoff table. The core of the bar is then allowed to air cool, which allows the outer martensite ring to be tempered by the dissipating heat energy. Fast air cooling from controlled temperatures also results in the formation of a soft inner core, which gives the TMT bar strength, combined with the ability to bend without cracking. After cooling on the cooling bed, the bars are cut to sizes of about 12 meters and then bent and bundled for shipment. Mechanical tests are done on each batch of TMT bars. The ultimate tensile strength, yield strength, and elongation property are measured during these tests. TI Macho TMT bars give a superior combination of yield strength, ultimate tensile strength, and percentage elongation when compared to other bars available in the market. The combination of these properties provides the ability to withstand higher shocks, higher loads, and increases structural life of buildings. Test pieces from each batch are also put through bend tests to check whether they have sufficient ductility. This ensures that the TI Macho TMT bars can be bent without cracking. It has been observed that many local brands crack on bend testing, especially in the cases of larger sizes. The Indian standards also specify a rebend test, where the bar is bent to an angle of 135 degrees. Then the bent portion is immersed in boiling water for 30 minutes. And then the bar is rebent in a way to open out the included angle to 157.5 degrees. The TI Macho bars easily pass this test as their microstructure is finely graded and their residual stresses are very low. Some local manufacturers misinterpret the rebend test specified by the Indian standard by repeatedly bending and rebending the bars and claim that it is a measure of superior quality. But this kind of testing does not prove anything, as this is not a performance requirement for the bar. TI Macho TMT bars carry traceability to the property ranges achieved during manufacture, Each bundle is tagged with a Know Your Right tag, which allows the customer to directly access the inspection records available on the internet. These bundles are then sold to the customer through our extensive dealer network. These are some of the reasons why you should consider buying higher quality TI Macho TMT bars for building a house of your dreams.